This video is going to cover Chapter 9, Section 4, which is partial fraction decomposition. So that's the first time you're hearing that term, partial fraction decomposition. And basically just what it means is you're taking a fraction and you're breaking it down into its sum or difference. So we are used to seeing a question like the right side of this equation, where you would get two fractions and you'd have to, and the goal is to put them together into one fraction. So you'd find the least common denominator, you'd multiply it by the other one's denominator, and then you'd combine your like terms and you'd end up with something like what's on the left. Now what's happening now, the decomposition or decompose, is the breaking apart of this. So we're going to take what's on the left and break it apart into what's on the right. So the steps for these are this, and again, this is a lot of words. I know this is not something that you're going to learn from, but when we do the steps, hopefully you'll understand these, and then if you get stuck, you can use this slide to come back to. So the first thing we're going to do is factor the denominator. Then we're going to split the fractions for each term in the denominator. So when we factor it, if it's broken into two terms, we'll have two fractions. If it's three terms, we'll have three fractions. The different terms are on the bottom, or the denominators of those new fractions. And then we're going to give numerators constants, A, B, C, and so on and so forth. So then we're going to rewrite the initial expression on the left equals A times what's missing from that denominator, B times what's missing from that denominator, and so on and so forth. We're going to find the values of X that are going to cancel those A's and B's out one at a time. And then we're going to find the other variable. And then we're going to P for all the constants and put them all back in at the end. Again, I know that sounds like a complete foreign language to you right now, but we're going to work through some examples and then hopefully you'll get the hang of it. So this is partial fraction decomposition. You're going to get given one fraction, like number 1, example 1. X plus 7 over x squared minus x minus 6. Step number 1 is factor the bottom. So we look at our denominator here and we say this is a trinomial. Factors of x squared would go in the first spot, and then I'm looking for the factors of -6 that sum to -1, which are -3 and +2. So we've got two terms there, which means we're going to have two fractions. A over the first denominator, x minus 3, and B over the second, x plus 2. Now the order there doesn't matter, because if you had factored it as x plus 2 and x minus 3, the order would just be switched, which is totally fine. You'll see it work out at the end. Now we're going to multiply each A and B by the other denominator. So I'm going to multiply A times x plus 2 and B times x minus 3. Now the long process of this would actually be multiplying the numerator and the denominator by that. And that's how we're able to do it, by changing both the top and the bottom. But we kind of skip that step because now we just look at our numerators. So I get x plus 7 equals A times x plus 2 and B times x minus 3. Now I want to solve for A and B one at a time. So the goal is to get what's next to it to be 0, so it cancels that out. So I can either ask myself, what would I plug into this x to cancel out that, making it 0? And I would hopefully know that it's x equals -2. And then I'd ask the same question on the B, what would I have to plug into x there to get that parentheses to be a 0? And it's x equals 3. The other way to see that is just go back to your factored form of your denominator, set them each equal to 0, and solve, and you get 3 and -2. Those are the two values you're going to plug in. Now we're going to do this twice. We're going to plug that value into everywhere there's an x in this or this, which is the same thing, statement. So I get x plus 7, so -2 plus 7 equals A times -2 plus 2 plus B times -2 minus 3. I get 5 equals A times 0, remember that was the goal, plus B times -5. This cancels out. 5 equals B times -5. Divide both sides by -5 to isolate the B, and I get B is equal to -1. Then I'm going to repeat that whole process, this time with x equals 3. So I plug the 3 in everywhere there's an x. 3 plus 7 would equal A. 3 plus 2 plus B, 3 minus 3. 10 equals a times 5. This is 0, so the b is going to get canceled out. 10 equals a times 5. Divide both sides by 5, and a is 2. Goal was to change these fractions so that when you add them, they get this. So my answer is actually those fractions with the a and the b put in their place. So the a, which is 2, is going to go over the x minus 3. The b, which is negative 1, is going to go over the x plus 2. And then we usually don't leave the negative in the top, so we would rewrite that as 2 over x minus 3 minus 1 over x plus 2. Now with extra time, these are easy to check because we work backwards. We would find the least common denominator between these two, multiply this one by the x plus 2, this one by the x minus 3, distribute the negative because it's a minus, and then combine them, and you should end up with the left side of your fraction. Okay, we're going to work through some more examples. So the next one, again, we start the same way. We say, can I factor the denominator? And this actually, on your notes, is just a minus. Otherwise, you wouldn't be able to. So you can disregard the plus that is there. It's a minus. So now you're looking for the factors of positive 2x squared to fill that first spot. So 2x and x. And then the factors of negative 1 so that when I do the outer and the inner, it sums to negative 1. If I do a positive 1 here and a negative 1 here, outer is negative 2x, inner positive 1x, and I get negative x. The other way to factor it is multiply first times last. 2 times negative 1 is negative 2. Factors of negative 2 that sum to the middle term would be negative 2, positive 1. Replace the middle term with those. And then factor by grouping. So take out the 2x, take out the positive 1, and I get x minus 1 and 2x plus 1. So either way you factor it, you end up with the same denominator, 2x plus 1 and x minus 1. So now I'm going to set these equal to a over 2x plus 1 and b over x minus 1. Multiply by the other denominator from whatever's missing. So this is going to get the x minus 1 and the b is going to get the 2x plus 1. And then I'm looking at just the numerators. X plus 5 equals a, x minus 1, b, 2x plus 1. I want to cancel them out one at a time. So I would need x to be a positive 1 and x to be a negative 1/2. On the left-hand side, everywhere there's an x, I'm going to plug in a 1. So 1 plus 5 equals a, 1 minus 1 plus b, 2 times 1 plus 1. 6 equals, this becomes 0, so the a is gone. B, this is 2 times 1 plus 1, which is 3. And I get b is 2. Plug in the negative half. Negative 1/2 plus 5 equals a. Negative 1/2 minus 1 plus b. 2 times negative 1/2 plus 1. I know this is going to be 0, so the b cancels out. I'd get negative 1/2 plus 10 halves here to get a like denominator, so that's 9 halves equals a negative 1/2 minus 2 halves, so negative 3 halves. Then divide by negative 3 halves or multiply by the reciprocal, negative 2/3. The 2's cancel, the 3 goes into the 9 3 times, and I end up with a equals negative 3. Then again, I want to go back to my original question and plug it in once I factored it. Negative 3 over 2x plus 1 plus b, which is 2, over x minus 1. And there is the decomposed fraction of the original question. Okay, let's work through some more examples. So 3x plus 1 over x squared minus x minus 6. Factor the denominator. X minus 3, x plus 2. A goes over the x minus 3. B goes over the x plus 2. Multiply out what's missing from the denominator. So A gets the x plus 2. B gets the x minus 3, and then I look just at my numerators. X plus 1 equals A times x plus 2 plus B times x minus 3. Now I want to cancel them out one at a time. Again, you can either go back to the factored form of your denominator to find what to plug in, or you can look at these one at a time. I know I need to plug in x equals 3 and x equals negative 2. Plug them in everywhere there's an x. So 3 plus 1 equals A, 3 plus 2, plus B, 3 minus 3. 4 equals A times 5. This would be 0, so the B is gone. And I get A equals 4/5. Now plug in the negative 2. Negative 2 plus 1 equals A, negative 2 plus 2, plus B, negative 2 minus 3. Negative 1 equals, this is my 0, the A is gone, B times negative 5, and then B is 1/5. So now when we plug these in, A gets the 4/5, x minus 3, and B gets the 1/5 over x plus 2. Now those are complex fractions, and we can't leave fractions within fractions. So the denominator of the numerator comes down to the bottom. 4 over 5 times x minus 3 plus 1 over 5 times x plus 2. Now, if your answer is open-ended, that answer is completely fine. But if it is a standardized test, they will then factor out the 1/5. So you would see it as 1/5 and then 4 over x minus 3 plus 1 over x plus 2. So they've taken that common denominator of 5 out of both of those and put it on the front. So WebAssign would take both answers. If it's multiple choice, you're going to see the second. So just keep that in mind. Okay, 4 is next. Same steps. Factor the denominator. This time it's a difference of 2 squares. 4x square rooted is 2x plus 7 and 2x minus 7. I get A over 2x plus 7 plus B over 2x minus 7. So set them each equal to 0 to multiply out what's missing here. And then look at your numerators. Then set them equal to 0 on your original factor denominator to figure out what you have to plug in. 2x would equal negative 7, x would equal negative 7 halves. 2x would equal 7, x would equal 7 halves. So first I'm going to plug in that negative 7 halves. I get 1 equals A, 2 times negative 7 halves minus 7 plus B times 2 times negative 7 halves plus 7. Now the negative is going to cancel with the positive 2x plus 7, so the B is gone. 1 equals A. This would cancel. I'd get negative 7 minus 7, negative 14. And A is a negative 1/14. Then repeat that process by plugging in a positive 7 halves. So A, 2 times 7 halves minus 7 plus B times 2 times 7 halves plus 7. This time this is the one that gets canceled. So I get 1 equals B. These cancel. 7 plus 7, So 1 equals b times 14, and b is 1/14. Take those and plug them back in up here. So a is negative 1/14 over 2x plus 7. And b is 1/14 over 2x minus 7. Again, the denominators can't stay there. And we can bring out the 1/14. So let's do that in two separate steps. It'd be negative 1/14 times 2x plus 7 plus 1/14 times 2x minus 7. Bring out the 1/14 and you'd get negative 1, which the negative can be out front like that, or it can be in the numerator, plus 1 over 2x minus 7. So short answer, either one is fine, but multiple choice, that 1/14 is going to come out. All right, so hopefully now they're getting a little bit more comfortable. These are tedious, I would say. They're not impossible. It's the same steps over and over again, so it shouldn't be too bad. Once you practice it, you should get the hang of it. Now, what makes it more complicated is when you have repeated factors. So if one of the factors, meaning the ones that are in the denominator, is repeated, such as an x squared or an x plus 1 squared or x plus 1 to the third, something like that, then you have to use the term to the first power and then the second until it matches the exponent. You cannot just factor this as x times x and do a over x plus b over x. You will never get back that x squared because the least common denominator of x and x is just x. So the way these work is you would have to factor it out. And then you would start with that term, if it's a repeated one, to the first power time, or then the second one would be at that one to the second power. Again, if it was x to the third, it'd be then x to the third. Then you'd have to multiply a times just the x, and b doesn't get an x at all. You'd get 2x equals ax plus b, and then you'd continue to solve it. And I'll show you how to do it. It's a little bit different this time. So these examples, again, definitely step it up a notch. If you look at this equation in the denominator and you go to factor it, you're going to take out an x and get x squared plus 2x plus 1, which becomes x plus 1 times x plus 1, or x times x plus 1 squared. So this is a repeated factor. I would get a over x plus b over x plus 1 plus c over x plus 1 squared. So that's how I would deal with the repeated factor. Now, the other catch on this question is that the exponent in the top is higher than the one on the bottom. So this has not happened to us yet. And if it does happen that the exponent in the top is higher than the exponent in the bottom, then you have to divide the numerator by the denominator to reduce it a degree to the point that it's either the same exponent or lower. So this goes back to long division, and it's been a little while since we did it. We have to rewrite our numerator and divide it by our divisor. What's on the end, on the bottom, or the denominator goes to the outside. And now we have to divide. So we go first into first. So what do I have to multiply x to the third by to get to x to the fourth? That answer is x. I would multiply that times each of the terms on the outside. X times x to the third is x to the fourth. 2x times x is 2x to the third. And x times x is x squared. Then we change our signs and add. This is going to cancel. This is going to cancel. 5x squared plus 20x plus 6. So we've now gotten it to the point that we've reduced it a degree, and our exponent is now equal to or smaller than your denominator. So that's the goal here. So now x is one of the factors that is going to be part of my answer because it came from here. I took it out. What's left is now what I'm going to set equal to the right side of my equation. So what's missing from the x is missing from the a, is the x plus 1 squared. What's missing from the b is the x and the second x plus 1. And the c is just missing the x. So then the left side of this, 5x squared plus 20x plus 6 is going to get set equal to, and you're going to break this apart. So if I expand this out, I get x squared plus 2x plus 1. So this would be a times that, x squared plus 2x plus 1. bx times x plus 1. We're going to come back and distribute that. And then cx is the last one. So I would distribute the a in here, ax squared plus 2ax plus a plus bx squared plus bx plus cx equals that left side, 5x squared plus 20x plus 6. So now what's even harder is I can't set these equal to 0 to figure out what to plug in, because this I would say 0, this is a -1, but this is also a -1. If I plug -1 in, it's going to cancel the b and c always. I'll never be able to solve it. So when you have a repeated factor like this, we do these a little bit differently. We're going to take and group together every x squared in our equation. So here's an x squared, here's an x squared, and here's an x squared. So I say 5x squared equals ax squared plus bx squared. Then I group together all the x's. So 20x, 2ax, bx, and cx. 20x equals 2ax plus bx plus cx. And then the only constant, 6, is equal to a. So we already have one variable here. We know that a is 6. From the other two equations, you can actually divide this entire thing by x squared. And I have 5 equals a plus 5. I can divide all of these by x. And I get 20 equals 2a plus b plus c. And then again, here I've got a equals 6. So we've actually created a systems of equation here that you can work backwards to solve. If we know a equals 6, then we can use substitution and plug that into the first one. 5 would equal 6 plus b, and b would equal -1. And then I can plug the a in to the a here, the b in, and I only have the one unknown left, which is c. And c is 9. So then when I plug it back in up here, the a is 6, so 6 goes over x. The b is -1, goes over x plus 1. The c is 9, goes over x plus 1 squared. And we cannot forget about the x we took out at the beginning to make it to the point that we could actually factor it. That would be the answer. And again, you can go a step further and take that negative off the 1 and put it in between. So x plus 6 over x minus 1 over x plus 1 plus 9 over x plus 1 squared. All right, that one was rough. I know it's rough. This I think these are the hardest of them. We're gonna walk through one more example like this, okay? But don't freak out just yet. All right, so the first thing hopefully you catch is that the x1 in the top is bigger than the one in the bottom. So I know I'm gonna have to divide here in a minute, but I can factor this first. I can look at the denominator and take out an x squared and get x plus 1. So not only am I going to have to divide, but it's also going to be a repeated factor. A goes over x, b goes over x squared, and c goes over x plus 1. Now again, completely separate from that is that the exponent in the top is bigger than the bottom. So I have to take x to the 4th plus x to the 3rd plus x 0x squared, because I'm missing the x squared term, plus x plus 4, and divide it by x to the 3rd plus x squared. Divide the first into the first, so x to the 4th divided by x to the 3rd is x, multiply that times both, x to the 4th plus x to the 3rd, change your signs, cancels, cancels, this would be 0 plus x plus 4, so this is gone as well. So now my numerator is x plus 4, so I'm doing x plus 4 divided by x to the 3rd plus x to the 2nd, and the x from the numerator is going to get added on to that answer at the end. All right, so now go back to my ABCs. A is missing the second x and the x plus 1. B is missing the x plus 1. And C is missing the x squared. So I'm going to use this numerator. X plus 4 equals, distribute this, ax times x plus 1 would be ax squared plus ax plus the b distributed here, bx plus b plus the c distributed here, cx squared. Now this time when I group together the x squareds, there's no x squared over here on the left, which would mean it's 0 equals ax squared plus cx squared. The x to the first would set equal to ax plus bx. And the 4 is going to set equal to the only one that's by itself over here, which is b. So I can't divide by the x squares on the left because this doesn't have it yet. So if I had 0x squared like that, then I would divide everything by x squared. Cancels it out, and I get 0 equals a plus c. Come over here, divide everything by x, and I get 1 equals a plus b. And then the last one is the one that's already solved, and b is 4. Take this, plug it in here, and I get 1 equals a plus 4. A would equal negative 3. Take the negative 3, plug it in here, and c is 3. Then come back up to the top to plug it in. So negative 3 over x is the a. B is positive 4 over x squared. And c is positive 3 over x plus 1. Don't forget about the x that you took out at the beginning. Okay, the last part of this is what happens if it is a non-repeated and quadratic factor. So in this case, you would not have the repeated factor, so different from the one before it, but you will see that your denominator will not factor further than an x squared. So if I had something that was x over, and I took out, let's say it was x to the 3rd plus 2x. When I take out an x here, I only get x squared plus 2, and I can't factor this any further. So this is the case we're talking about. It's quadratic and not factorable. In that case, when we split it, the single term here would get the a, but the quadratic term, instead of just getting b, gets a bx. This should be a plus c. It gets a bx plus c over whatever that second denominator is. In this case, x squared plus 2. Then you would multiply out by what's missing and then regroup it the way that we just did. All right, so it would look something like this. 3x squared plus 4x plus 4 divided by x to the third plus 4x. So the numerator in the top is not bigger than the bottom. It's not the problem we had before where we had to divide. So I go straight for the denominator to factor. I take out an x and I get x squared plus 4. This is not factorable. So I get a over x plus bx plus c over x squared plus 4 because, again, that denominator is quadratic and can't be factored. Now multiply out by what's missing. So the a gets the x squared plus 4 and the bx plus c gets the x. Distribute that out. Just looking at my numerators, I get a x squared plus 4a plus, and the x goes to both, bx squared plus cx. So we cannot cancel them out one at a time this time because this will never equal 0 is one of the issues, right? So I'm going to do the same thing we did the last time. Group together all of the x squareds. So you'd get 3x squared equals ax squared plus bx squared. Group together all the x to the first, and I get 4x equals cx. Group together all of the constants, and I get 4 equals 4a. Divide everything by x squared, and I get 3 equals a plus b. Divide everything by x, and I get 4 equals c. And then this one, I can just divide by 4, and a is 1. So I've got a is 1, I've got c is 3. I can take the a, plug it back in here, and b is 2. So it plugs back in. The a would be 1 over x plus the b is 2 and the c is 4. So 2x plus 4 over x squared plus 4. And there's my decomposed fraction with a repeated or non-repeated factor, that is quadratic. All right, that's it. So you can use, please make sure you submit your notes. Okay, to today's assignment so that you can receive full credit for that classwork assignment, and then use the rest of the time to work on the homework. And remember, you're going to get the 25 minutes in class. It's short tomorrow, but you're going to get the 25 minutes in class tomorrow to also work on those homework questions. Have a great day, guys.